Now, like we mentioned, the default gateway is the way out of town. This is the way to the internet. So this is from your local network out to the big wide world of the internet. DNS, of course, is a little bit of a different animal. DNS is sometimes something that people don't quite understand fully, and that's okay. Most of the time, it's not something that you need to worry about. However, there are times that you lose your connection to this telephone directory or this internet directory. And if that happens, sometimes it's difficult to get to a web page on the internet. And a lot of times your customer will have the perception that they've lost their connection to the internet. Well, they may not have, they may actually have just lost their connection to the DNS server. So this is how this works. Again, I'm going to use the example of ESPN.com. And like I mentioned, when ESPN says, hey, we want to be the website address, ESPN.com, it has to register and it gets assigned an IP address to that domain name. The reason why this becomes important is because if you think about it, we as people don't necessarily remember numbers nearly as well as we remember names and words. So I would be willing to bet that most of you could remember the name ESPN.com. But if you had to know the four different numbers separated by a dot to get to ESPN and all of the other websites that you ever want to visit, that would probably be a little bit more difficult. For an example, when's the last time you dialed a phone number by memory versus scrolling through your phone and just dialing or just clicking on the button and having the number dial automatically? So here's how this works. ESPN has this website or this IP address that's assigned to it, and that IP address and the name get associated in the global DNS. And DNS stands for Domain Name Service. And really what it is a name to number translator. And it basically associates the number of the IP address number that is assigned to a particular web address. When your device actually says, hey, I want to go to ESPN.com, did you know it's actually not going to ESPN.com? Where it's going first is to that address book. And it says, I want to go to ESPN, but your device does not understand names. It does understand numbers. And so the global DNS, or this directory, translates for you and says, okay, I understand that this name is associated with this IP address. So let me send the IP address back down to you. Your device now says, okay, cool. Now I understand what to do with a number. And so it sends that number out to the internet, which then gets it to the ESPN website. And the ESPN website says, okay, and I understand that you have a request coming in. Let me send you my website back. And that's how it works. Now, most of the time, this works really, really well. However, there are some times where you lose the connection to that telephone or that internet directory. And if that's the case, it's pretty difficult to be able to type in the name of a website and be able to get there because you've lost your connection to that translator. We'll talk in a moment about how you can verify that and troubleshoot that. But that does happen sometimes. And that's why we talk about setting up your own DNS IP addresses. Instead of relying on whichever it is that the ISP decides to give you, you actually have the ability to set your own in. And this is a screenshot of the main quick setup page that's the default page of our routers. And usually in this spot where it says primary DNS in gray, it will say IP address assigned by ISP or obtained by ISP. And that's perfectly fine if you want to leave it that way. However, if you want to just kind of reduce the chance that you might lose connection to that particular address book, you can change it over to something like Google's. And if you do that, like I said, it's not a guarantee, but it does greatly reduce the chance that you may lose connection to that address book. It just adds a little bit of a stability layer to your network. DDNS is something you've probably heard of that works a little bit differently, and this is much more common with camera systems or surveillance systems because you want to be able to view that camera on your phone or your tablet from outside of the local network. The problem is, just like in regular DHCP, the IP address that the service provider hands to that network or to that modem also changes all the time. And so if you have an IP address that's external that's changing all the time, well, how does your phone know where to go to get that camera image? And that's why we have DDNS, which stands for Dynamic domain name service. And dynamic, of course, means that it changes. So what happens is you set up a DNS or a DDNS inside the router. And basically what that does is it now keeps track of the external IP address coming in from the service provider. And anytime that changes, it then sends that update information to the DDNS provider for whoever you've chosen. In this example, we're using DynDNS, but there's lots of them out there. You can use whichever works best for you. DynDNS then says, okay, well, I understand that this IP address has changed to this particular network, so I need to update that in my global directory. And so it sends that update to associate the name of the DDNS with the new IP address number. And so again, when your mobile device says, hey, I want to go and access my house and my surveillance system at my house, I go again, not directly to the house, but to that address book translator. And the translator says, yes, I've just been updated. I know which IP address this is. Let me send it back to you. And the device says, great, I know what to do with an IP address. Now I know where to go, and I can go and hit that router and get into that and view my surveillance system or whatever it is, whether it's a VPN, works the same way. That's what DDNS does, is dynamically tracks the external IP address from the ISP, and the router has the capability of updating that so that that name to number translator is always current with whatever the IP address is that's associated with that name. The bottom line with a lot of this is please do yourself a favor and make a template of how you want to have your networks laid out. Obviously, when you have a bunch of devices on a network and you have 254 IP addresses that are available, you have the option to have them be anywhere on that network. Well, you also have the option to categorize things a little bit and make it so that, like I said earlier, no matter what technician goes out to the job, they always know where your devices are going to be. If you always have your camera system and it's always set on 192.168.0.210, for example, that's the NVR, and then the cameras are above that, that's perfectly fine. Of course, you don't have to do it that way. This is just a suggestion, but the point is please categorize things and make it so that whatever you do on networks is duplicatable and repeatable, and you're doing it all the time so that your networks become a little more easy to maintain in the long term. Again, like I said, bottom line here is documentation can sometimes become key, especially if you're dealing with a lot of static IP addresses and you need that automation system to know where those static IP addresses are. Documentation can become a key thing for you rather than having to try and hunt them down every time something happens and you need to either change something or troubleshoot something. So let's talk about troubleshooting for just a moment here. Like I mentioned earlier, sometimes you can lose your connection to that name to number translator or that DNS server. And so when a customer calls you up and says, hey, I've lost my connection to the internet, well, first of all, my question would be back to them, well, have we really lost connection to the internet? Or is there something else going on? So you get on site there and you connect up with your laptop, and the first thing you want to identify is, does your device get an IP address? If it does, then you know that obviously the local network there is working. Whether you're Ethernet or wireless, you know that it's working because you connected, you asked for an IP address, and you received one. The next step is, can you log into the router? And usually if the network is up and running, then yes, you'll be able to log into the router. Well, how do we do that? Well, of course, that's the IP address of the router. So you go to a internet browser, type in 192.168.0.1 or whatever the IP address of your router is, and you should be able to see that user interface. The first thing I want to check when I get into that router is, does it have a WAN IP address or an external IP address? And this is, of course, going to be the address that's coming from the service provider's modem. If it does, you know it at least has an IP address out to the external world. If it doesn't, then maybe the router has gone down or something happened there, and that's where you know the connection problem is. But let's say that it does have an IP address. Well, can you ping the router's default gateway? Well, you should be able to. You should be able to ping whatever the IP address is that's coming in from the external modem, because that's the next hop in the system. Can you now ping? And the next thing I would do is ping 8.8.8.8 and try to ping something on the internet, which in this case, of course, is Google's DNS server. If you can ping that, if you can see it, then you know you have connection to the internet. If you get a reply back saying, yes, I can see this. If you don't, then you know that potentially you have a problem with the ISP not having service at that particular moment. One of the tests that's easy to do is if you can ping 8.8.8.8 and you do get a response, but then you ping www.google.com and you do not get a response, you immediately know that your problem is the DNS server and you've lost your connection to that. Because you can get there when you type in the exact IP address, but you cannot get there when you type in the word. So that name to number translator is lost its connection. And like I said, a lot of times this is why people use Google's or OpenDNS's IP addresses, because their servers tend to be a lot more stable and up and running than a lot of other ISP servers. So it's just a nice little best practice to use. The last thing I want to talk about in troubleshooting is what happens if you see an IP address on your device that starts with 169.254. Some of you may have seen that in the past. And to explain this a little bit, back in the day when Microsoft and several other networking companies were developing how networks were going to work, they said, well, there's going to be a problem sometimes. The problem is that a device is going to ask for an IP address, but no one is going to be on that network that can answer that and give them an IP address. So the device is going to have to do something. And so what they determined was the 169.254 is going to be when no DHCP server is found, the device will assign itself that particular IP range. So if you see a device that has this, starts with 169.254. something, you know that that request for an IP address has been asked, but not received. It doesn't receive an IP address, and therefore that device cannot talk to anything on the network. So if you try to have that device communicate with anything else, obviously it will not happen. So just as again, a best practice there, if you see this particular IP address scheme, you know that that means that something's not working right and that device is not actually on the network that you need it to be on.